gentlemen. Today we're talking about section 8.4, which are properties of rhombuses or rhombi, rectangles and squares. All three shapes should be familiar to you. They're all special types of parallelograms. So all the properties that apply to parallelograms also apply to rhombuses, rectangles, and squares. But in addition to the properties of parallelograms, they each have their own special properties as well. Let's start with the rhombus. The rhombus is a special type of parallelogram because it has four congruent sides. Where in a parallelogram, the opposite sides were congruent only. In a rhombus, all four sides are congruent to each other. The second shape is the rectangle. It's a parallelogram, but what's special about it is that it has four right angles. So all the angles are congruent to each other, and they're all right angles. Like a parallelogram, only opposite sides are congruent, not all four like in a rhombus. And I like to say that if a rhombus and a rectangle had a child, that child would be a square. Because a square has properties of both. It has four congruent sides like a rhombus and four right angles like a rectangle. So a square is a special type of rhombus. A square is also a special type of rectangle. So a square is actually both a rhombus and a rectangle and a parallelogram. So it's the most special of them all. A nice way to sum this up is this Venn diagram that I would like to show you. And the entire thing is a box that contains parallelograms. Within the category of parallelograms, you have a rhombus, which has four congruent sides. You have a rectangle, which has four right angles, and a square, which has both. So a square is a rhombus, a rectangle, and a parallelogram. A rhombus is a parallelogram, but is not always a square. A rectangle is a parallelogram, but is not always a square. So a square is a rhombus, but a rhombus isn't always a square. A square is a rectangle, but a rectangle isn't always a square. So for any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So to draw a sketch here about a rhombus, I know that I have all the sides are congruent, and this is QRST as the problem states. And again, we always label clockwise. So is Q always or sometimes congruent to S? Well, that's going to be always, because a rhombus is a parallelogram. And in any parallelogram, whether it's a rhombus, a rectangle, a square, or just, Joe Schmo parallelogram, the opposite angles are always congruent. So that's always congruent in any parallelogram, including a rhombus. For part B, would angle Q and angle R, these consecutive angles, always or sometimes be congruent? Well, it's actually sometimes. In this picture, angle Q is obtuse while Q is obtuse while angle R is acute. However, if I had a special rhombus, aka a square, then angle Q and angle R would be congruent because they're 90. So angle Q and angle R would be congruent only when the rhombus is a square. That's why it's sometimes. Let's try something else. For this problem, classify the special quadrilateral. Explain your reasoning. Well, looking at the properties here, we have four congruent sides, which means it's a rhombus or possibly a square. But since there are no right angles, just a 70, and this would be 70. We have no right angles so far. We can't assume these are right angles, so this has to be a rhombus only. So this should be a review. We should remember some of these things about rhombuses and rectangles and squares. But let's look at some specific properties you may haven't seen before, or you might haven't seen. The first one, theorem 8.11, in a rhombus, the diagonals are perpendicular. So parallelograms, diagonals bisect each other, which is true because rhombus is a parallelogram, but they're also perpendicular in every case. So to illustrate that, here I have a rhombus, and as you can see, these diagonals are perpendicular because I have some right angles. No matter how I change the shape of this rhombus, I always have right angles in the middle. No matter how I change the shape or anything about it, as long as it's still a rhombus, those diagonals are still perpendicular. The second property says the diagonals bisect the angles. So as you can see here, these are both 46s, and so are these. So this diagonal bisects the angles. And same thing with the green ones. Since these are both 44s, they're cut into congruent halves, which means this is a bisector. And no matter how I change the rhombus, it's always bisecting the angles. The two halves are always congruent. So 8.12 says in a rhombus, diagonals bisect the opposite angles. And you can see a nice example picture to the right. Finally, in a rectangle, diagonals are congruent. So not only do they bisect each other, but they are congruent. So all four halves are congruent, and the whole thing, the whole pieces are also congruent. And one last little illustration with the software here. Here I have one diagonal is 6.3, as well as the other. And no matter how I change the orientation, the width, height, those diagonals are always remaining congruent. If you'd like to finish copying these down, please pause the video. Otherwise, we'll be moving on to 2 examples before we finish. So sketch rectangle ABCD and list everything you know about it. So here's ABCD. There's a lot of things we know. I mean, first of all, we know it's a quadrilateral with 4 sides. We also know it's a parallelogram, since it's a rectangle. And since it's a parallelogram, we know that opposite sides are going to be parallel. So we can say that AB is parallel to DC. And we can say AD is parallel to BC. We can also say opposite sides are congruent. So we can say AB is congruent to DC. And we can say AD is congruent to BC. And since it's a rectangle, we know all the angles are congruent and all of the angles are 90 degrees. So I'll say angle A is congruent to angle B, which is congruent to angle C, which is congruent to angle D. And they all equal 90. Also, I know that my 2 diagonals are congruent because this is a rectangle. So AC is congruent to BD. And I also know that AC and BD bisect each other because it's a parallelogram. There's quite a few things we know here. You might have different numbers if you split some of these up separately. We could go separately and say all these halves are congruent instead of the whole things. You could split up number 7 into several different statements, but this is a summary of everything we know about this if it's a rectangle, a lot of information. If you'd like to try this on your own, try this one with a square. And we know even more special things about a square than we do a rectangle, because a square is also a rhombus. So we know everything about a square that's true about a rectangle, and everything that's true about a rhombus. So if you'd like to try this one on your own, it could be an interesting thing, and see how many different pieces of information that you can find. And we're going to classify the special quadrilateral and then find the values of x and y. So let's do number 11. When we have all these sides congruent, so we know it's a rhombus or a square, and since we have right angles, we know it's a square. And I just explained it verbally. So if this is a square, we know all sides are congruent. So to solve for x, we can set our x piece as equal because we know all the sides are congruent. So 5x minus 4 equals 3x. And subtract 5x from both sides. We have negative 2x equals negative 4. So x is 2. We also know that these sides are congruent because it's a square. So 2y plus 4 equals 5y plus 1. And to get all my y's to one side, I'm going to subtract 2y from both sides. So these cancel. So 4 equals 3y plus 1. To get y by itself, I'll subtract 1 from both sides. So 3y equals 3. Which means that y will end up equaling 1, and there's my solution. If If you have any other questions you'd like to ask, please email me or see me before or after school. Hopefully this video is a little bit helpful.